good.
Okay, I forgot to start recording, but yeah. So maybe I can go back a couple of them. So we already, oops, sorry. Yeah, we already talked about the elite performance and how throughput is related to lead time. It was a slide about me, just very quick, and the agenda. And we talked about the paradox of local optimization. So the bottom line that the local optima is not the same as global optima. Okay. So now, and this is Dr. Eliyahu Goldratt said that. Okay. So now let's talk about this very interesting excerpt from the Agile Coach report. I think this is Agile Coach report. So leadership is a barrier to implementing agility. The most prevalent challenge, and this is like 0-1, like challenge number 0-1. The most prevalent challenge that Agile coaches reported was that leadership and management tended to be a barrier to agility. They cited a variety of reasons, including lack of buy-in and support, resistance to change, having a mindset that was not conducive to agility, being rooted in older management styles, lack of understanding, and the lack of alignment between agile teams and leadership. So all kinds of problems. So how do we, as agile people, professionals, overcome them? How do we talk to this group of people? How do we explain everybody why local optimization is so bad? Why more is not better all the time? Because you see, this more is better is a concept that is it needs clarification. It's not always true. Not always true. That's why local optima is not equal to global optima. Okay, so let's think about it. Okay, so getting buy-in from people in power. So when you talk to people in power, like VP level, director level, typical questions from VP level, when you start to talk about improving performance and you say, I'd like to help you to improve performance, they say, when you talk about increasing throughput, sorry, throughput, not performance, throughput, and say, when you talk about increasing throughput, do you mean we need to hire more people? Or they say, when you talk about increasing the speed of delivery, do you mean that people must work longer hours? So typical questions, so expected. And also typical managers and teams, even teams assumptions, you know, kind of traditional assumption is that assigning work to a specialist is the most efficient. If you always assign work to a specialist, it will be the most efficient thing to do, right? The other assumption will be to solve a business problem, we first need to understand which components are impacted, and then we need to split between the teams specializing in those components. It's not happening every day with us. This is like the core of the corporate environment, right? And the last one is the faster each team works, the better. So the more is better. So very, very typical assumption, very typical assumption. And the thing is, I hope that the answer to all of these questions and all these assumptions is no. That's not the case. We are not going to add more people to increase the throughput. We are not going to ask people to work longer hours to increase the speed of delivery. No, that's not the case. We are not going to assign work to specialists, and this assumption is actually hurting us. No, we are not going to split the business problem between the teams specialized in that component. No, that's not the case. And by the way, more is not always better. I'm guessing I'm very confusing at this time. So I'm going to clarify what I mean. and hold me accountable. If I'm saying something wrong, tell me that I need to go jump in a lake and cool myself. All right. So, all right. Let's imagine this. This is a production line, and on the production line there's a kind of like a factory. It's like, let's call it blue factory. Okay, and there's a backlog that goes from down to up and goes on the production line and moving in the direction. Okay, and it comes to that factory, and this factory producing other boxes, yellow boxes, right? And on the other side, there's a customer, and customer get those boxes and all happy. Is there any problem with this picture? No, not yet. I mean, the factory takes 3 boxes and the output 3 boxes and everything is happy, okay? No problem. But what if there's another factory, yellow factory on the way, and they need to work one after another? And then yellow factory will produce some other boxes, from they will take yellow boxes and produce red boxes and then ship to the customer. So what is in this case? Okay, so everything is good on the paper like this. Why? Because we assume that the yellow factory and the blue factory work at the same speed. What if not? What if, and let's assume for the sake of this example, let's assume that yellow factory is working slower than the blue. What's going to happen? This is going to happen. The work will start to pile up in front of the yellow factory. Naturally, right? And then if we say that they are producing a little bit less, that means it will be not 3 boxes out, but only 2 boxes out. Okay. And again, this is very, it's a model, in real life, it could be a little bit different, but just for the sake of explaining what local optimization is, I'm trying to depict the problem. There is a different groups of people working on a different speed, but they're depending on each other. Because the end result, the red box, is only shipped when they're processed by 2 different groups. Okay? The work is piling up, but also what is happening, the yellow boxes, while they're processing, there could be something that is not quite right with them after they process by yellow factory, and they could be returned back. Something orange in them, something orange, not quite completed. They say, please go and look at this again because they are not so good. And at the same time, with all our good intents, the yellow factory also can produce some of the orange boxes, not quite red, and ship it to the customer. And then what happens is customer also will return those orange boxes back and say, like, it's not quite done. We need to redo them. We call them production defects and non-production defects, for example, right? So there will be some returns. So what could be a problem in this picture? And we probably can notice some of the problems start to pile up. What do you think?
I just think you're going to have pile-ups everywhere. Like what's going to get, like you can ship one, like one thing out of that's like a very low percentage,
Yeah, so
brain.
If you can't keep the rates linked, things will pile up all over the place. Yeah.
Yeah, so if there is no delay on the shipping part, so it will be shipped very quickly, essentially. How quickly the customer will return it back depends on how quickly customer get to those boxes and verify them. We have no control over it.
Yeah.
So that's going to be at some time passed after, a customer will return this to us after a while. Okay. What else may happen? Apparently, customer was involved when we actually put stuff on the left side, on the blue side, in the backlog. So customer probably wanted some of this, stories, whatever, converted to red boxes and shipped to the customer. And probably there's a time between that thing will go, the blue box will go into the backlog, and between the time the customer actually evaluates that. So if you look at this, processing, we will see the big pile in the middle, and the time the box will stay in the middle, and the time it goes back and getting a rework in case it needs a rework. All of this included in the final feedback from the customer.
Mhm.
Also, those items that are waiting for feedback from yellow factory also will be taking time before they even return back to the blue factory to rework. And what that means, and in some teams, it could take days and weeks and sometimes months before the same item is looked at it again and reworked. This is dependent on how big is this pile. Okay. So what usually happens is if the pile is so big, and obviously there's a lot of defects returning, and there could be a perception that the yellow, if managers look at it, they may say, well, the yellow factory is slow. We need to figure out why the yellow factory is slow and make it faster.
Mhm.
So because there's a perception that more is better, and they will look at isolation in different, different factories. They will actually put all the focus on the slow item, on the slow part, and they will try to optimize the bottleneck, the slow part, the slow group. And they will think like, okay, those guys cannot figure out how to do things. We managers are so smart. We'll come and help them to do things faster. And what they do very easily. First of all, they put a lot of attention, a lot of pressure on this group and start to say, okay, guys, tell us what you do. We need to do more meetings. We need to do more reports. We need to, I don't know, do something about this. Let's cut corners and let's don't process that much. Let's go faster. We have a pile in front of us. Hurry up. What's gonna happen? We're gonna have a pile of done stuff, but most of them will be done poorly. Because of this pressure, because of shortcuts, we will lose control and quality, and we will have more orange items rather than red. Yes, we will have more stuff there, but it will cause more returns from the customers. And it happens everywhere, in every organization that apply this method. So now, how do we call those boxes, the blue and the yellow? What do you think could be names of those boxes? The blue factory and the yellow factory.
Yes, this could be like production or development and delivery or dev and ops or
Like dev and QA, very typical. We hire developers and we hire QA, and developers must develop and QA must test. Yeah, and they heavily dependent on each other. Nothing is move forward unless it's tested, right? And who gets the push? QA gets the push, and they cut corners. I've seen this so many times. Some smart architects come in and say, well, let's skip those tests and don't do them. And what we have in next day, we have a production disaster. It's happened to me many times. Okay, so you can call it UI and DB. Have you seen this pattern that DB is a sacred department that only work on tickets and they slowly process? You need to put the tickets months in advance, something like that, or middleware in DB, whatever, right? But it could be any team. It could be team from component A and team from component B, and it will be the absolutely same thing, especially if team component B is closer to DB and data storage. It usually happens like this. Oh, we have DB component, and then they slow down the whole organization. Yeah. But in order to be more versatile and kind of looking at the big picture, we as agile professionals, we should look at bottlenecks. And then we need to see what depends on bottlenecks. Okay. So now let's talk about the parameters here. So the first parameter is the lead time. The lead time is longer the bigger the pile is. So the bigger disbalance between the two, the bottleneck and non-bottleneck, the longer the lead time. Also, the more defects returning back from the production, the less intake you have. And the less the intake we have, the more we rework on the stuff. And actually it may not actually reduce the work for the bottleneck. So all of this stuff will go through the same assembly line. So even if we rework, we just repeat the work, that's it. So that means the lead time increases because with the less intake, and also customer perception about us is that we kind of need to do the same work several times before they're satisfied, okay? That you may also include it in the lead time, unless we get it exactly right, okay? We have a time here on returning from the bottleneck to non-bottleneck, let's say QA to development. That could be also impacted by the pile that is here. So because the QA can take to verifying something that was submitted months ago, it was just staying in the backlog, not in the backlog, it was staying in the lane of the board. So imagine you have many stickers in some lane, right? And it's lane ready for QA, for example. And there are 20 items there, and all of them older than a month, right? So that's another time impact, okay? And finally, the time of the customer feedback, also important parameter here. So lead time. Now, how lead time is connected to the throughput? That's an interesting question. Oh, there's another parameter here. The percent of complete and accurate. That's something that could measure. And by the way, you remember the throughput? Maybe I can return back to the slides that I shown before. So this one. So you see this lead time here is a throughput. Is a throughput metric because it's green. You see the in the green here, throughput. So also the guys are in DevOps report. They also it's actually DORA report and DORA metrics, and they say change failure rate. So this change failure rate is pretty much how many times we fix the same thing again and again, over and over again. So. So this is also a metric that is important to track, okay? Okay, now, interesting question. Is there any problem with this picture? Let's say there's a brick wall and we have one box and we ship stuff, you know, we convert blue boxes into yellow boxes, and we get some feedback over the wall, and we say sometimes yellow boxes come back, sometimes orange boxes come back to us. Orange boxes, that means they've been in the customer hands already. Is there any problem with this picture? The answer is no, there is no problem, because we consider this system is in isolation, and we are going to optimize it in isolation, and we are going to just do our best to take the intake and process it. So we cannot actually optimize the system if we just look at the blue box. We need to look at the system together in coordination between the blue and the yellow, the whole value stream. Unless we optimize the whole value stream, nothing's going to change. Okay, it's going to perpetuate. Okay, so I talked about this with the different teams, and this is what they say, what the teams, what they say, what ideas they have to improve the situation. So you may hear something like that: remove pressure from the yellow factory to avoid orange boxes. Stop the blue factory producing yellow boxes. That's another idea. Just don't pile them up. It doesn't help anyone. make blue factory help yellow factory to work on the pile, the yellow pile, okay? Make blue factory produce red boxes right away. Oh, that is a good one, okay? So it bypass, it doesn't need to take time from yellow boxes. And then increase the throughput of the yellow factory and automate yellow factory, okay? So let's see how it works, okay? So first of all, what's gonna happen? If we remove pressure, let's say we remove pressure from the bottleneck,
Mhm.
QA department, what's gonna happen? They will produce less output, okay, but also that means there will be less returns. Just simply because we produce less, it will less returns. And the next step would be is to enable the blue factory to help the bottleneck. And the blue non-bottleneck essentially needs to kind of change between blue and yellow. So if you're talking about developers, maybe they can start doing something that will help to work on this pile, and they can, you know, help to make it this pile less, or maybe eliminating that. And this is very counterintuitive, because in managers' mind, the most efficient way to work is when you assign a specific task to a specialist. And developers are non-specialists on testing. First of all, they could be actually more expensive to do that. And also developers may not like doing testing at all. And they may say like, oh, what's going on? I'm not hired here to test, right? So, but the thing is, as soon as we start to say non-bottleneck, start to work on the pile and help the bottleneck, what's going to happen? Input decreases. So we will start taking less blue boxes as an intake, because we will be actually working on yellow boxes, okay? What else will happen? We actually may convert some of the yellow boxes to red boxes, and because we join forces, we have more time to do things, we can do a quality work, we actually will have less defects in production. What does it mean? That means decreasing the amount of orange boxes returning back to the development. That's another consequence. Do I go too fast? Maybe I'm starting to say nonsense by now.
So this is fairly abstract. It'd be fun to discuss some of the kind of realistic implications when you're ready.
Well, think about this as stories, and those stories go through the Kanban board, and they stay in different lanes. Before development, in development, after development, before testing, in testing, and then done. Right? So this is kind of like how the stories go through the Kanban board, and how the defects come back, production defects come back, and how also defects circulate during the sprint before they are shipped to the customer. Something that the team actually finds about the system, okay? Okay, let me finish connecting those variables, okay? So what else is, if they actually start to produce the red boxes right away, the developers group or the non-bottleneck team start to produce red boxes that are ready to go. And we're talking about here of a blue factory having two skills, essentially. The skill for blue factory and skill for yellow factory. So we now start to talk about cross-functionality. If the team is trained to do multiple things with quality, they can actually ship it to production, bypassing bottlenecks. And that's a huge advantage, okay? So let's say this red box go right to production. So what that means, actually, we start to increase the output. And this is a ridiculous situation. When the input decreases, then output increases. It's like very counterintuitive. But But if you have a pile of work in the middle, this is exactly what happens. Okay, so what is the next step? Let me see.
Well,
Okay.
then you could just get rid of yellow.
Yeah, then orange will be
Oh.
kind of like once in a blue moon. So you will have even less defects coming from the customer. At this point, customer could actually notice that something is much better, recently. Okay, so what next is improving? We may get rid of this whole pile, and if we get rid of this whole pile, this is where the magic start to happen. Okay, if we get rid of the whole pile, then the next step, we get rid of the delay. And this is where you see, this is where the clock disappears on top. We start to get a faster feedback. After we did something, we have a faster feedback about some problem. It becomes almost instant. So once we finish with the processing on the blue factory on this step, we have feedback right away that something needs to be worked a little bit more. We drop the switching context, we gain the time there. And also because the people become multi-skilled, they actually can test and pretty much do at the same time and only start to produce the nice clean yellow boxes. So that being said, we have less, or we don't have decreased input because we don't work on the pile anymore. We can intake as before, but at this, which is very beneficial. And input actually increases because of this. Why input increases? Here's why. If we start from the very beginning, the input may be very high, and then it decreases. But once we get into the vicious circle of getting a lot of defects and a lot of pile, the team actually and they live with these defects for months and years, and they get used to the slow processing. But once you get rid of the pile, they notice that they can actually take more work, more than before, more than the worst state, in other words. Okay, that's why I'm saying input increases. Okay, increases comparing to having a pile of work in the middle. Okay, so so the lead time becomes shorter. Why? Because once we get the blue box, it streamlines right across to the red because there are no bottlenecks. So the yellow bottleneck become non-bottleneck because the their other one helps to process as needed, pitch in when needed, and do that. Okay, so and then faster feedback from a customer as well, and customer getting satisfied much more as well. So this is kind of like the end game here. This is where we intaking more, we output more with better quality and getting faster feedback. So this is and have shorter lead time. This is how lead time is actually connected to the throughput of the system because some inefficiencies are removed out of it. Okay. And by the way, this is the meetup called Influential Agile Leader. You can take this model and you can talk to any team about this. And this is how you show them, like as ABC, how it works essentially. I have something else, but I would like to hear your questions here. So maybe can stop at this point.
So I think that a simple application of WIP limits and flow gets rid of most of the queuing problems. And the real application of local optimization comes when the development process is optimized at the cost of the up and downstream processes. For instance, there was an old agile practice of the definition of ready. We're a team and we don't take work that's half done. And so until you meet the definition of ready, I don't even want to talk to you. Made the work of the development team so much easier. They didn't have all that half-finished stuff. But it actually impedes the whole flow enormously.
That's right. That's right.
And now that we kind of don't talk about the definition of ready anymore, we say, if that needs help developing, why don't you come talk to us and we'll help you figure it out, right? Now we've got optimizing the flow instead of the local process.
That's right. That's right. So I appreciate that you mentioned work in progress, because work in progress is another variable I didn't mention here. So essentially we're saying here, the work in progress here is set up the way that there is no traffic jam, right? So when we talk to leadership, we say we're improving throughput. But when we talk to the team, we say we focus on work in progress. So we say we focus on lead time, because all three of them are directly connected to each other. So you decrease WIP, lead time shortens, and throughput increases. But how it happens, you need to tell a story about this, because it's not quite intuitive.
Mhm.
So for me, again, the doing the standard whip or flow things within a team, take care of the piles and the inefficiencies.
Yep.
But it's easy to optimize the development piece and ignore everything else.
That's
Have you
right.
ever
So,
read Flight Levels, Klaus Leopold's work? He's got, let me see if I can find it. Oh, here it is. Here it is. Here's his cover illustration.
oh,
Yeah.
rethinking agile. Yeah.
Rethinking,
Right,
yep,
the
yep.
team in the middle has made themselves super agile, and now the process is fixed. But if you look at the part around it, it's this huge long process that's full of inefficiencies and
Yeah.
annual funding and monthly sign-offs and things like that, and annual releases. And this part in the middle is just completely wasted optimizing that. It's the flow you need to optimize.
That's right. That's right. Exactly. So this is exactly what happens. And when we actually talk to the team about this, and we say, hey guys, you have too much work. You have too much work for QA and waiting for QA to do things. And by the way, the mere fact that the team has developers and QA, it's already a red flag. It's already a red flag. Okay. But when you actually look at the board and you see 12 items ready for QA and nothing, before the dev, and QA is having another 6 item working on, you can say like, hey guys, it's a lot of work on QA. What do we do about this? And what they will say, well, we do what we can. We try to do as fast as we can. And they think that we try to put pressure on them. But we actually need to say, well, I'm not talking to QA guys. You guys relax. You do what you do. I'm talking to developers now. What do you do about this? And they will say, well, we developers, what are we going to do? It's not our work, right? But this is happening at scale as well. You may have teams to have exposing the same language. They say, well, we component A team, we're not component B team. What we can do about this? Yeah.
Yeah.
But the problem is absolutely the same. It's universal. Take any big system with multiple teams, find the bottlenecks, and find how the bottlenecks impact others, and then work on non-bottlenecks. Don't work on bottlenecks. Well, you can work on both, but and bottlenecks, more is better. Just equip them with the best tools, and let them help them. But non-bottlenecks need to learn multi-skills, and you need to create cross-functionality. Yellow, blue, which is
cross-functionality is the easy way to solve it, but they have 3, right? The theory of constraints has 3 solutions, right? The deprecate the bottleneck. What are the technical terms? I use the non-technical ones.
So Dr. Eliyahu Goldratt is saying that the technology is improving. Technology is improving the situation only is removing the limitation only if oh gosh, I need to recall that. So the technology is improving the overall performance only if it's removing the limitation and we adjust the rules that were accommodating that limitation. Well, that's actually the crux of it. So we need to remove the limitation by technology, but also we need to change the rules that we're adopting to work around this limitation, right? So there are 3 steps that you need to go there. Okay, so that's the crux of it. So if you talk to the team and you say we focus on reducing WIP, or we say we focus on and shortening lead time, it's actually easier to perceive and track. And there are tracking tools that are actually telling you exactly what's the WIP, and they warn you when your WIP is go up. But with WIP, actually, you need to see the WIP at all places throughout the process. It cannot be like we have one big pile in one lane and that's our WIP. No, the work needs to be actually streamlined. And that's why I'm saying it's much easier to focus on lead time, because if you focus on lead time, you know how long does it take from the blue box to entering the production line and the red box exiting the production line. And this is the throughput that Dora actually put in the elite performance metric. Lead time is 7 times faster in elite performers organizations. That's why they elite performers, because they have higher throughput. Okay.
I mean, I understand, exactly what you're saying, but I'm a little confused about, like, obviously there's no detail around the complexity of which each of those factories is doing. So how do you know that you've got, optimization in terms of the number of, QA people or developers? Are they balanced? And does that, how much does that matter?
Yeah, how do you practically apply it? First of all,
Yeah.
we can see it right away. If you open any board for any team, you look at the board, and in version 1, for example, there is a special option on the board to enable, so you can display the little clock on each item. How long does it stay on the board? If you see something like 50 days, that means you can work on shortening lead time. That means throughput is not optimal, okay? And also, if you start to see piles here and there in different lanes, ready for analysis, ready for development, ready for QA, ready for deployment, ready for anything, if you start to see piles, that means there is a disbalance between this. And especially if you see this over and over. And the third thing, if you have a huge backlog of defects, that's another indication that there's this balance. And actually this bottleneck, the QA group needs to focus on improving the quality versus focusing on improving the throughput. This bottleneck team cannot further improve the throughput. It's exhausted.
The last place I worked, we hired a heavyweight Java tuner, Java developer, whatever, or not Java, I'm sorry, a Jira developer. And we optimized our Jira implementation. And the one really valuable thing was he was able to put that counter on the cards. So you could see how long things were sitting there. And that's incredibly revealing, especially if you put kind of both the local and the global. So you put the local for the team, this has been in your queue, your sprint backlog, whatever, for 7 days, and you think, oh, we should get that moving. But then under it, you put the big number. This was submitted on July 19th, 2012. It's been sitting in the backlog ever since. Like, whoa.
655 days.
That's right. That's right. And those were not uncommon to see ones in hundreds of days that had been submitted and just kind of went round and round and stuck in the process.
Yeah, languish, throw it away.
Right.
Can't be valuable anymore.
That's right. That's right. I know that's one of the solutions, is to just literally throw away anything that you can't do now. It'll come back if it's important.
Yeah.
Yeah, yeah. I'm waiting for a time when those companies who develop those boards and agile tools would come up with the indication of cost of delay. That will be absolutely awesome then. It's kind of like the value that the value will decrease every day for every item.
I've,
Mhm.
I've
Yeah.
had trouble using cost to delay. You know, I read, or at least I tried to read the Reinerson book. It's kind of thick and 279 formulas or something like that. Flow. I don't know if you've looked at that one. It's not an easy read. But he says everywhere, cost delay is the magic metric. You put it in, everything works. Except
Yep.
I can't get cost of delay. I mean, I want it. I realize it's valuable, but
Mhm.
here we are writing some code. What happens if your code was delayed 6 days, 10 days, 20 days? How much would it affect the revenue of the company? That
Right.
is really, really hard to calculate.
Yeah. So usually it's not an accounting, it's a forecast. And the difference is that's not in the past. We cannot really put an exact number on it, only after it happens. So for example, if I say I wanted to buy Tesla stock yesterday and it was $1,000, and today it's 1,100. My cost of delay is 100, but I know about this only after it happened.
Right. But
Mhm.
worse
So
than that,
yeah,
like even in the reasonably simple cases, you know, you delivered the feature 7 days late and you give it to the customer and they say it's about time and they shake their fists at you. Okay, so how much badwill was that worth? How much revenue did you lose because of that? Was there a customer who would have bought it who didn't buy it because it was late? I don't know. I could spend my whole life trying to figure out that number.
But you might have also been penalized by the government because you didn't deliver. And that'd be a pretty easy number, like you just got fined $500,000.
That's right.
So
Sometimes
yeah,
there are these hard
not as
numbers.
often as say delivering new product feature functionality for sure. So
I,
It's just
I,
every time I've tried to use that in an equation, I just don't have anything useful to fill in for it.
looks
um,
like
I,
Maru has an
uh,
idea.
yeah, Maro, go ahead. What is your opinion?
Yeah, I wanted to share how these cost of delay things are actually being used in strategy, because my background is in strategy. That's where I spent the past 8 years, strategy consulting. Before that, I was a postdoc and a junior prof. I did my PhD in AI and model-driven engineering. So I was quite a weirdo in the world of strategy because they did technology strategy work, but none of them had any technical background. In fact, they considered engineers like, they call them techies, and they had this arrogant view towards them, which is full of despise. That's why I left, because there's a profound misunderstanding of the work that what they refer to as techies do. But the one thing that I learned from them is the way they have them. I mean, I used to belong to them, but anyways, Reinhardt worked at McKinsey, and the stuff he did and developed was actually from that perspective, from that world on manufacturing and production engineering, and that's why I'm very much attracted to him. By the way, just a small excursus. The Poppendieks come from the same world, but not the strategy world at all. They come from the industrial world, and that's why a lot of the very useful stuff that for me combines very well, works very well with TOC and in general flow methods.
Yeah.
Also is lean software development. What I wanted to share was the way these guys work with cost of delay. Here's how it goes. It's actually extremely simple. It's all based on, like with all models, it's based on assumptions. That's the magic word that you can hear that in the mouths of consultants. But we as engineers, me at the beginning, I was thinking, yeah, who the hell cares? What's that? Where is that? Is it an informed assumption? Is that a proven assumption? Is that a mathematical one? Because all my models that I learned as an engineer, when I was doing simulations, I worked a lot in data mining and warehousing in beginning of the 2000s, and also did a lot of process simulation, process mining for intelligence, for audit, for compliance management, for verification, formal verification. And then I meet these guys, and all they do is the thing that you can actually only know for real once it has already happened is not at all a problem. All you need, like in projections, financial projections, is making assumptions. And that's what you use to base your work on. In the end, they factor in something that in the world of business or strategy, they all know is you cannot know. All you do is have your opinion or your models or simulations or whatever data you acquired or built or historical projections that do not predict the future like his stocks. However, you take them and you say, I'll work with them. And it's not even half a page, half an Excel. It's just a short Excel tab and here, I got my cost of delay. It means nothing to an engineer, but for them, because it has to be exact and true and nobody can know the future, but to them, it's a working tool. They only need to evaluate for several alternatives and then say, okay, for this one, this is my cost of delay, and therefore I'm going to plan my work differently. That's what I wanted to share with you guys.
Thank you. Thank you so much for sharing.
But if it's all squishy, you know, I understand it's going to be perfect, but if it's all squishy,
it's not squishy. It's not squishy at all. It's extremely well done. In fact, these assumptions very, very often are confirmed in the 98th percentile. They're not making some dump out of a back of the envelope, out of your guesstimates, not at all. Estimations or hypotheses are actually the result of a very disciplined engineering method that they use. So they will know exactly what that flow is about. Who is that coming to? For example, they will know exactly what that kind of car is going to bring them on average, looking at the markets, the conjecture, the economical conditions, their competitors, the predictions for pricing, for gasoline price, whatever, for servicing, for materials. They will include a lot of models, a lot of parameters in the models, and they will say, this is how much, on average, each one of those 100,000 cars that I wanted to manufacture in that region in the coming 3 months is going to bring me, and therefore every day of delay is equivalent to so and so much dollars.
Yeah.
so in a single product manufacturing, I can see that. But what I'm always faced with in teams is, you know, here we are with this backlog of things. You know, we can work on this thing to improve the security. And if we do, we might prevent one of those billion-dollar security breaches, or we can work on this one that'll clean up that glitch that everybody's been complaining about, or we can work on this one that might open up a new market. Well, you know, how big is the new market? What would be the size of the security glitch? How much of the people are complaining and what's their likelihood of leaving? As soon as I put those all together, it turns to mush. I mean, I can't get any useful numbers in that. I can make it prove anything I want.
Yeah, that's why they work with assumptions. For example, the example you gave with the security glitch is a perfect one. That's the exact same thing that people do in valuation of companies. How do you want people to know the exact value of a company when analysts tell you, we value the stock at so much and therefore it's underpriced, and we expect the target price of this stock to be at this level for the next 12 months or 1 year? What does that come from? It just comes from these informed hypotheses. For example, I would like assumptions. So a concrete answer. Her example was very good. The security glitch. All I'm going to say is, in my company, we use the model that says that the financial impact of this glitch combined with this probability or likelihood that it will occur for your type of company is so much multiplied by this likelihood, but this risk, so the likelihood. Therefore, the financial impact that we think our solution, that we are telling you our solution is going to have on you, that's going to avoid you in terms of costs, in so much. Therefore, you're just paying 5% of the price to take our solution in. And that's how the whole business world works. And so another company might come. Of course, there's a risk of, there is every next company tells you, oh, no, the impact is actually twice what the other analysts told you. And therefore, there is an element of trust and validation of models. So nobody questions the papers by McKinsey or the reports by Gartner or Forrester. You know, they say, okay, we trust these guys. We're not going to go and calculate and recalculate every single assumption they did. So I agree with you. There is an element of gray zone there. But, they do have methods. That's my point. Methods are not exact.
So this is not a science. This is art, if you would. And this is the job of the business people, actually, to guide and lead business in a certain direction. This is how they do this. And essentially, well, I like the method that I learned from Joe Justice, how he calculates the cost of delay. And he's saying, I'm asking the simple question: how much would you pay for this feature to be delivered today? So, and those people, who are in business, they can scratch their head and say, well, I would pay 800,000. for this feature. If you deliver it today, and this is how they calculate that the cost of delay, or it could be another question: what price do we need to pay if we don't do this? So like we don't secure our system, what price we need to pay, and what is the
Yeah.
likelihood of that happening? So, and we
But that's
multiply
exactly
them.
what happens. That's what he's saying is not just some guy doing some crazy stuff at Tesla. That's exactly what happens on a daily basis. That's why you can get different values inside the same company
Yep.
or the same department from two different experts, or very radically different valuations or values from two different companies. That's just the way it is. Nobody can predict the future. So that's in economics. That is how actually people learn about the concept of value at the beginning. People ask these kind of questions, and then everybody in class is shooting numbers, and the professor shows you that what has a value of $1,000 to you has a value of $100,000 to another guy. He uses the example of water here in South Park or in the desert, and that shows you how subjective all of these things are, including cost of delay. It has an element of subjectiveness, definitely.
Yeah.
Well, back in the 60s, there was an economist, was Jay Forrester, I think, and he came up with this global model that showed we're all going to die. We're going to use up all our resources. The population is going to peak, and everything's going to collapse. And we thought, oh my gosh! And here's the model to prove it. It was 27 variable model or something with differential equations all over the thing. And then people started to play with it, and they said, well, if you assume that the cost of grain per acre is 28 cents, it goes like this. But if it's 26.5 cents, it goes the other way. And if you adjust this, and it turns out the whole model can fall apart, a dozen different ways. As soon as you get complexity in models, the fine assumptions make huge differences. And so you get total mush out of the results as a decision-making framework. So I have lost confidence in models. And in fact, as a kid, I had this idea that if people only understood how our economy worked, we wouldn't have all these fights. And so I was going to develop just this simple 6-variable model of the economy. You could just turn the knobs and it could go up and down as a teaching tool. And I couldn't make it work. So I went to a professor at Georgetown University and showed him my problem and asked him just to help me with just a simple model. And he looked at me and he just stared at me. I remember now, he says, kid, models prove whatever you want them to. And then he sent me away.
That is absolutely true. I remember when I was a computer science student, my teacher in AI told me, Marwan, don't forget, numbers are small, little, weak creatures that you can say whatever you want them to say. And that's the attitude I took with me throughout the years, doing so much applied math and stuff. But the thing is, the purpose of a model is not at all to be exact, not at all. Otherwise, we wouldn't have made so much progress. We've been breaking and destroying models, including string theory models that are being destroyed right now because we're discovering so much more new stuff. The purpose of a model is to be useful, to guide you to a decision. That decision, on the opposite to exact sciences, where I come from, I'm a hardcore engineer. In the world of business, which is where we deliver software, it's not an exact science. So the purpose of a model is to lead me to the best decision. So the quality of my decision will depend on 2 factors. First, the quality of my model. How useful is my model? Not on its accuracy, the quality. That means fit for purpose, accuracy of the model, etc. And then the other factor is how well do I use my model? If I overcomplicate my model and I fall into pitfalls like, for example, TOC proposes a model, extremely simple model. I mean, you can explain this stuff to a child. You probably understand it way better than me, actually. I don't know if you guys agree. That's my impression. That's part of the talent of this guy, Goldratt. Is that stuff, if you look at it, it hides a lot of complexity in a very simple model. And that's one of the, at least that's how I view things. Anyway.
Yep. Thank you so much. I will share the last slide here with a little bit of promotion of what I do, just for the records, because I'm recording this call. Well, take a screenshot or join the calls. Reach out to me. I'd like to connect with everybody, and LinkedIn. Stay in touch. I love conversations about agile, improving performance, moving the groups to companies to elite performers. I have still seen a lot of potentials, and though today it was a rather impractical conversation, it is practical from one perspective. When you discuss with the team and when you discuss with your superiors, with the managers, senior management, you can actually lead them to certain conclusions that certain things are important and we need to pay attention to them, such as lead time, work in progress, the number of items done correctly from the first time, the percent of completed and accurate, and that is actually impacts the throughput and customer satisfaction and enable us to do better products, serve customers better, keep them happier, and collaborate with them more. It actually, we are buying time by doing this. So thank you so much for your support. I will stop recording right now, and maybe we can, I don't know, we can drink tea together and chat a little bit more. Thank you so much.
Thank you.
Yep, thank you. So I'm stopping recording right now.